So, hello everyone. I'm gonna present you Aidge, which is an open source platform that has been hosted by Eclipse Foundation. So, in today's day and age, AI is becoming more and more advanced and more mature. And we think that with maturity of AI going up, there will be a need to go to edge deployment instead of what we're doing right now, which is more like a cloud-based development. So to do this, we need to have a solution that will allow us to easily switch from our neural network that has been trained with your favorite framework, for example, PyTorch or TensorFlow, into edge device. Doing this can be very hard, especially you have multiple challenges. The openness challenges. Indeed, right now, most of the SDK are proprietary, which means that if you developed your application for a specific hardware, then you will need to do it all again if you want to switch hardware. So this is going from reusable and adaptable tools. The independency is very important and very key, as you want to be free to choose the material and the component you want. And innovation, it's important to stay up to date, especially in the AI development. So yeah. This is why we propose Aidge, which is a framework that allows you to load your model from your favorite framework, train it and optimize it. And once you have your optimized model, generate code in order to target specific hardware. To do this, our platform is available in GitLab, hosted by the foundation Eclipse. It's coded in C++ and Python, and it's available on most platform and packaged on PyPy. You can find it with a very lightweight modular core and a different plugin that you can use in order to keep a lightweight product. So I will talk about the Aidge in three different use cases: the import, the optimization, and the deployment of your neural network. For the import, we have a strong interoperability with ONNX, with more than 60 operators that are right now supported and many more to come, as well to support to generic operators if you want to create a custom operator. We support also most of the main embedded architecture. Once you've loaded your model, you can easily, with Aidge, assess the performance and the complexity of your model. For example, looking for bottleneck in computation or in a number of parameters, which then you can fine-tune your model using the optimization available in Aidge that we'll see later. And finally, the last point on import models, which is the modification of your graph. Aidge proposed a very novel graph matching model that allows you to match part of your graph and to apply transformation onto it, allowing you to create dedicated transformation to target one specific hardware. For the optimization, as I said, you can target your model and then simplify it. Here's an example where we have a shuffle net layer, which is then dividing the memory by sex. We also support state-of-the-art quantization. So we support post-training quantization and quantization-aware training, which allow you to go to up to 4 bits. And then we also have tensor decomposition. So these compression methods are really at the state of the art, and right now we are having, for example, higher performances than M8, which is the Qualcomm framework. Then, if you want to deploy your model, we also support fully an integration with ONNX, which allow you to export your model to ONNX and then target the device you want. For example, using proprietary tools such as CubeAI, TensorRT, OpenVINO, and many more. The other aspect is the transparent deployment. This means that at each step of your optimization, you can see what has happened, and what is the state of your graph, what operation you're really doing into the graph. And this is done by creating source code in C, C++ instead of providing a binary, which means that you can review the code that has been generated by the platform. And of course, the platform is multi-target, which means that you're not stuck with one hardware. And completing on the openness of the framework, you have access to open schedule. For example, you can easily see the scheduling of your layers as well as the memory mapping of your application. This means that it's really easy to understand what is happening and how your model is running. So this project is supported by France 2030, and right now we have like 40 contributors and many industrial collaborators, and as well as academic partners, and many use cases. So one of the first use cases that we'll present is ArcelorMittal, which is using Aidge to detect default in metal sheets that are going 20 meters per second. So they needed a very high-speed performance model detection. We also have EDF, which is the French energy. So that's use Aidge for indoor localization with multiple sensors. So both visual sensor as well as an EMU, and the deployment on a STM32 hardware. Heat pump is also a project that showcased deployment on STM32, and the final project is NeuroCorgi, which is a project that where we created an RTL generation in order to create specific hardware which map the neural network into it, which means that we have a specific hardware for the neural network, which brings very good performances in terms of latency and power consumptions. So thank you very much for listening, and if you're interested, you can follow us on LinkedIn or join us on the Matrix chat. Thank you.